A very good morning, students. We are back with our structural geology video lecture series, and today's topic of discussion is the Ramsay's classification of folds. So far we had seen as symmetrical fold, asymmetrical fold, overturned fold, recurrent fold, plunging fold, non-plunging fold, then isoclinal fold, chevron fold, all those classifications, right? So we had almost covered some 30 types of folds, right, according to the geometry, where here Ramsay actually classifies all these 30 into 3 broad categories, and this video is all about that. So how we are going to classify all those 30 under 3 heading, that is what we are going to see. So let us see what he says. Actually, this is John G. Ramsay, who developed a geometric classification of fold based on the relative curvature of the inner as well as outer arc of a folded layer. So when there is a bed, say we have a bedding plane, right, that is the top end and the bottom end of a particular bed. When it folds, so that is what he used to call it as outer arc and inner arc, instead of saying top of the bedding plane and bottom bedding plane, right? And he used this thing for the classification. So let us see how it is. The line that join point of equal dip, and he used to call it as a dip isogon. So he coined the term dip isogon, which means the line. So say let this be the bed, and this is your bottommost layering, and this is the topmost layering bedding plane of this particular bed, and this is the inner arc and this is the outer arc what we are mentioning in the text. Okay, so a dip isogon is one which connects a equal dip. That is, if this point is say 30 degree or something dip amount, then this point also a 30 degree dip. So that is what a dip isogon is. That is a line that connects equal dip value in a folded bed. Okay, so with this he was classifying the fold into 3 broad categories, as you can see: class 1, class 2 and class 3, where class 1 is further subdivided into A, B and C. So let us see what are the classification, but before that we should know why we should go for this sort of classification. Okay, so the reason for following Ramsay's system of classification, fold classification. So the very first reason why we have to follow this is it connects fold geometry with formation mechanism. So we had classified fold in a different way, and we had mechanism of folding like flexure, shear, flow, right, that we had made in the previous video itself. So there is no any connection between the types of fold and those mechanisms, but here what he is trying to explain is there is a relation between the fold geometry as well as its mechanism. So that is what he want to explain in this classification. Then actually this classification allows field geologists to distinguish between types of fold based on observable structural parameters. So if you are in the field, you can use this dip isogon and thickness to classify a fold, where measuring a dip isogon and thickness is not a big deal when you are in the field. So with the field equipment and the field observation, you can go for this classification, because sometimes what happened in the field, when you are classifying the fold, sometimes we used to call something as a symmetrical fold. A close friend of us used to call it as a chevron fold, and sometimes the professor used to call it as a plunging fold, right? So this could happen many times for someone in the field, right? So those sort of differential terming will be reduced if you follow this classification, okay, where we are only having 3 broad classes and some few subdivisions there. So there may not be any sort of confusion, quite easier for us to name the fold in the field itself. Then the third reason is that it helps infer deformation history and rock mechanical properties from the fold shape. So the shape of the fold, the change in the thickness and all those things is mainly based on the competency of the rock itself. So from this classification we can also connect the rock's rheology with the folding mechanism. So these are the 3 main reasons why we should go for Ramsay's classification. Is that clear? Okay, let us see what he is classifying, the 3 broad categories, all those things. So the main base for the classification is the dip isogon. That is what mentioned in the first slide itself. That is a line that connects point of equal dip in outer as well as inner surface of a folded layer. So this is a folded layer, right? So you can see this bed has been folded, and this is the upper bedding plane, and this is the lower bedding plane. When it bends, we used to call it as a outer arc and the inner arc. So this arc will be having different angle at different location. For example, if you are in the axial plane, then the dip of this particular location is 0, as well as here also it is 0. As you move down towards a syncline, somewhere the limb changes orientation, right? At that point, this limb will be like a vertical. The same way this side also you'll be getting somewhere a vertical orientation, right? So likewise in a bedding plane, that is a arc, that is outer as well as inner, there will be different dip angles at different dip locations, starting from horizontal to vertical. Is that clear? So by using this dip value, he used to connect a line that is having same dip amount both in top as well as bottom, and also it follows all along the bed. Say this point, if it is say 30-degree dip, the same point here connecting the 30-degree dip all along the bed. So this line is a dip isogon. If you found a 40-degree dip in both the side, you can connect that. If you find a 90-degree dip also, you can connect that. So this is how dip isogons are made. By using this as well as the layer thickness, he classifies fold into class 1, class 2 and class 3. So these are three broad categories. In class 1 there is three subclasses, that is class 1A, class 1B and class 1C. So what is class 1? So the dip isogon for class 1, you can see here, is converging towards the core of the fold. So you can see this is a dip isogon, which means all along this line the dip amount will be same. So you can see here this is somewhere near 40 or something, the same value will be here. This is somewhere near 30 or something, the same value will be here. And this is 20 degree or something, the same way it is here. So the dip isogon having equal value actually is converging towards the core of the fold or the axial plane, right? So this is called as class 1. In class 2, what they are saying is the dip isogon are parallel to each other. So you can see all the dip isogons are parallel to each other. And in class 3, whether here it is convergence, here it is parallel, so this should be divergent. So class 3 is a divergent nature of the dip isogon. So you should be thinking why it is happening, right? So this is due to the curvature of the folded bedding plane. So if you see class 1, you can see the inner bedding plane is more curved than the outer one. So you can say this layer as a open fold comparatively when compared to this one, which is somewhere near closed fold, right? So you can see the outer bedding plane is less curved than the inner bedding plane. If you see class 2, you can see both are having same bending. That is, see, if you call it as an open fold, you have to call the same thing as open fold, because both are having equal or almost same interlimb angle. Is that clear? So this is why it is having a parallel nature of dip isogon. And when you are seeing the class 3, you can see the outer portion is more curved than the inner one. So this is what the outer arc, right? So this seems to be a closed fold, whereas this seems to be an open fold, where you can see the 30 degree that appears here is closer to the hinge. 40 degree that appears far away from the hinge is actually closer to the hinge here. So this portion is more curved than this one. So these are the three broad categories. Let us see the subdivision of class 1A, 1B, 1C. You can see the main difference between these three just by seeing the appearance, that is the thickness. So you can see the hinge portion is having a lesser thickness when compared to the limb portion here. And in this case, you can see all along the beds is having same or constant thickness. And in this case, in 1C, you can see that this is having lesser thickness when compared to the crust, right? So this is how class 1 is further subdivided into 1A and 1B and 1C. Is that clear? Okay, so as I said earlier, I will try to give a field demo or practical explanation for this fold. So to do so, we have to do the first step is we have to draw a cross section from the field, or you can draw, you can take a photograph from the field, right? So this is a field photograph from Narthamalai Pudukkottai, where you can see some different folds here, right? So in this we have to select one single portion and we have to draw the dip isogon. So I choose this portion of the fold, where you can see it appears to be somewhere anticline, right? So I will just choose this and I will draw the dip isogons here. That is, this all along the line, the dip amount will be same. That is, if I measure a dip amount here, it is 30, then in this also to be 30. The same way in this side also. So I had drawn the dip isogon. After drawing dip isogon, we have to find whether the dip isogons are converging, parallel or divergent. Just by seeing, I can say this is converging towards the core of the fold. So this is convergent in nature. Then we have to measure the limb and hinge thickness. As it is converging nature, it falls under class 1. So according to the thickness, we have to classify it as 1A, 1B or 1C. So we have to measure the hinge thickness. So here you can see the limbs are broader when compared to the crust, right? So the limb is quite broader than the crust, hence it falls under class 1A according to Ramsay's classification. Is that clear? Okay, I had given you some reference in the beginning of the video which you can use for your further reading, because this is just an outline. You need more reading about this to find what it is there. And actually we had started a new website, that is sggeology.com, where you can find our YouTube channel videos in a proper sorted way. And also there is a jam preparation section which you can use for your exam preparations. And probably I was planning for making a net preparation quizzes also there, that you will do it further. Thanks for watching. Have a great day.